Hey there, we're going to look at 6.1b today, finishing off our 6.1 lesson, and this will be on solving linear systems by graphing. And so we're going to just take a look at three quick examples today on how to graph these systems and to find their solutions. And so here we go. We're not even doing any word problems today. We're going to save those until next semester. We're going to talk about those in intermediate algebra. We're just going to look at the bare bones of graphing these systems today and getting them solved. All right, so example 1a. Solve this system by graphing. We have y is equal to 2x and y is equal to negative 1/2 x plus 5. And so with that, what we're going to see is we need to graph these two lines. And I'm going to use two colors here. I'm going to use red for the first line, and I'm going to use blue for the second line. So how do we graph y equals 2x? Well, this is in slope-intercept form. And so I'm going to have an m, my slope. Remember, that's the part attached to the x in slope-intercept form. And so that's 2. And our y-intercept is the b, but there's no plus or minus back here. So what would be our b? Well, if there's nothing there, it is 0. And so to graph this line, come to our coordinate plane. My y-intercept is 0, so that'll be the origin. And my slope is going to tell me to go up 2, and remember we make that a fraction, so we're going to go up 2 and right 1. Now, when we deal with systems, we want to graph these lines as long as we can so that we can see where the possible intersection might happen. And so we'll continue this line up all the way, continue our up 2 and right 1. We'll also reverse the pattern and go down 2, left 1. We'll reverse both directions. So if I go up and right, that reverses to down and left. And so this is the red line. This is y equals 2x. And so now we're going to look at the blue line and do the same thing. Ask yourself, what is the slope and what is the y-intercept? Well, the slope of the second line is negative 1/2 because that's the part in front of the x in slope-intercept form. And our y-intercept is the part that's added or subtracted at the back, and that's the 5. And so when we graph this line, we're going to put our y-intercept at 5. And my slope's going to tell me to go down 1, right 2, because remember we'll associate the negative with just one, not both. So down 1, right 2, down 1, right 2, and we'll continue this pattern. Now we already see where the intersection's probably going to happen, but I just like to make these lines as long as I can so I can see where they're going. And the potential, we can double check our mistakes. And so drawing this line through, we see this. And so the solution to a system of equations is where these two lines intersect. And so they intersect there. And what is that ordered pair? Well, it is 2, 4. And so that would be our solution. Now, can we check our solutions? Of course. So to check our solutions, this is what we did yesterday. We will plug that ordered pair back in and make sure it verifies. And so if I've got y, we can do this in red, y equals 2x, I'm going to substitute in the 2 and the 4. And so I'm going to get that 4. Is that equal to 2 times 2? And of course, 4 is equal to 4. So it checks for that one. But I've also got to check it for the blue line. Because remember, for a system, it has to work for all of the equations, not just one. And so I'm going to get y equals negative 1/2 x plus the 5. And substituting our order pair 2, 4. 4, is that equal to negative 1/2 times the 2 plus the 5. And so negative 1/2 times 2 is negative 1. And so I'm going to get negative 1 plus 5. And negative 1 plus 5 is 4. So that side also checks out. So 2, 4 is our solution to this first system. All right, so let's look at example B. So we have 2x minus 3y is equal to 6, and y is equal to 4. So we've got a couple of lines here. One's in standard form, and the other is just a one variable line. And so let's deal with the standard form one first. And so 2x minus 3y equals 6. Remember, we have one of two methods that we could use to graph this. One is we can find the two intercepts. The other is that we can solve for y and get this into slope-intercept form. Again, I like to solve this for the two intercepts. And so remember, we're going to plug in 0 for that y. And so I'm going to get that 2x is equal to 6. And dividing by 2, I get that x is equal to 3. And if I do it for the y, I'm going to plug in 0 for the x. That part cancels. Negative 3y is equal to 6. Dividing both sides by the negative 3 means that y is equal to negative 2. And so when I go to plot those 2 points on the coordinate plane, again, this is the order pair 3, 0. This is the order pair 0, negative 2. These are two separate points. Don't forget that when you're doing this. So I'm going to go 2, 3, 0. There's my x-intercept, and 0, negative 2 is my y-intercept. And if I look at my graph, I can see that the slope is up 2 and right 3, and so I can continue that pattern further along the graph. And again, down and left to reverse those instructions. And so again, I want that line as long as this graph will allow me to do, and draw the line. Now we'll deal with the blue. Well, that is the line y equals 4. Where is y equal to 4? Well, it's any ordered pair that has the y coordinate being 4. Well, 0, 4 has that, and 2, 4 has that, and negative 6, 4 has that. All right, so all those ordered pairs have a y value of 4 because that's what that statement says, y equals 4. And so I'm going to draw my blue line going horizontally across the coordinate plane. And again, we see a point of intersection. That is the solution, is where these two lines intersect. And that ordered pair is 9, 4. Now remember, I can test this. Now for the second equation, y is equal to 4. Oh, no, y is equal to 4, so we get it, right? But for the first one, we just need to plug it back in and check that solution. And so doing that, we're going to get 2 times the 9 minus 3 times the 4. Is that equal to 6? Well, that's 18 minus 12, and 18 minus 12 is 6, so that does check out. And we did check it for the blue because, again, our y coordinate is 4, right? So this does check out. So again, it doesn't matter what type of equation I'm given, the key is being able to graph it on the coordinate plane and then being able to see where those two lines intersect, okay? So the last example we're going to look at is, again, just two more lines, and again, I'm going to label them red and blue. First one will be red, second one will be blue. Colors don't really matter, it's just a reference for you to know which line I'm talking about. And if you have colored pencils or if you're doing this on your computer, you can do the same thing. Use two different colors for the two different lines just to keep reference. Alright, so the first line, x plus y is equal to 5. And so, it's still in blue. So, x plus y is equal to 5. And again, we could either solve this for the y or we can find the x and y intercepts. And so, x plus 0 equals 5. So that means x is equal to 5. And that's the order pair 5, 0. Because I plugged in 0 for the y. And 0 plus y equals 5. So y is also equal to 5. And that's the order pair 0, 5. Because I plugged in 0 for x, and I got 5 for y. And so plotting those 2 points on the coordinate plane, 5, 0, 0, 5. And we'll see that my slope is down 5, right 5. And so I can go down 5, right 5 again here. And I can go up 5 and left 5 and up here. And really our slope is negative 1 if we look at the boxes that we're going through. And so with that, that's our red line, right? So now let's do a blue line. This one is in slope-intercept form, so ask yourself, what is the slope? What's the y-intercept? M is equal to what? Where is it located? It's attached to what? The x, right? So our slope is what? Come on, y'all. It's 2/3. And the b? That's right, it's 1. And so when we plot this up, our y-intercept at 1, our slope's going to take us up 2 and right 3, and up 2 and right 3, up 2, right 3, down 2, left 3, down 2, left 3, down 2, left 3. And so drawing my blue line, we see that they cross, but can you tell me what is the ordered pair of where they cross? Well, it's somewhere between x being 2 and 3 and somewhere between the y being 2 and 3, right? And so we could estimate this. We could say that it's at like maybe like 2.3 for x and maybe like 2.7 for y. Again, we're guessing here because it doesn't intersect at a very nice point. And that's the issue with graphing, is if it doesn't come out very nicely to a nice answer that's going to look pretty on a graph, graphing is not always the best method. Again, it's a very visual method. It's easy to see where the solution is going to happen, but again, it may not be the most precise method. And so that's what we're going to look at when we get to section 2 for Friday and section 3 in our final week of the year, dealing with solving by substitution and elimination. Is we're going to see how we can accurately, precisely get these solutions. Now I'm going to show you how this will work for both of these, and you'll see that it comes out very close. This isn't the precise answer, but it is very close. And so if I check it for the first line, the red line, 2.3 plus 2.7, is that equal to 5? Yeah, because 5 equals 5. So actually 2.3 and 2.7 is on the red line. So that actually is a point on the red line. It's precise because it worked out. Let's check the blue. This is where it's going to fail just barely, and I'm going to show you how we can get this close enough to know what's going to happen. So y, which is the 2.7, is that equal to 2/3 times 2.3 plus 1? And so 2.7, 2/3 of 2.3. So we put that in our calculator, and what we're going to get, 2/3 times 2.3, is 1.5 with 3 repeating. And so 1.53 plus the 1. And so I get 2.7, and 1 plus that's going to give me 2.53. So those don't match up, but they're pretty close, right? 2.7 and 2.53, they're pretty close. So we can tell that we're close to this answer, but it's not precise. And again, that's why when we go to section 2 and section 3 of this, we're going to see better ways to solve this to get decimal and fractional solutions. So that's it for today. There are 8 questions plus a bonus question at the bottom that is a word answer. So again, you'll have 8 questions where you're just asked to graph the systems and find their solutions. And again, don't forget to check them. And I did give you graphs at the bottom of the assignment that if you want to print it out, or if you're doing them on screen, you can just do your graphs on the screens. Please make sure you number them. And so the word of the day is graphing. Again, the word of the day is graphing. And make sure you get that done for me. And y'all have a great day.